We are probably one of the most automatized guitar factory in the world. The way we approach tops, our voicing and bracing, we brought some great things recently with CNR Active. I think it's a very advanced way how to construct your neck. Since I'm more like an analytical person, I kept kind of like going this direction more like with more like a scientific approach. Already kind of trying to figure out how to make the polishing and buffing somehow automatized, and so our finish are polished by robots.
These are not your grandpa's acoustic guitars. Hidden deep in the countryside of the Czech Republic, inside an old mill, a beautiful ballet of man and machine, operating in almost clockwork precision, produce some of the finest acoustic guitars I've ever laid hands on. Marrying tradition and skilled handwork with advanced robotics and scientific measurement, Furch Guitars are at the forefront of producing high-quality, European-made stringed instruments. While they are innovating across the entire design and production process, Furch have three main areas of focus to improve the performance of their guitars: soundboard voicing, stable humidity-resistant necks, and advanced polymer finishes that aim to enhance, rather than kill, resonance of their guitars. Ask any guitarist what are the most important aspects of your guitar, and they'll tell you how it plays, how it looks, how reliable it is, but most importantly of all, how it sounds. For an acoustic guitar, sound is produced when the player strikes the strings. This vibrational energy is transferred to the guitar's bridge, and from there spread throughout the soundboard, the thin, resonant, solid wood top of the instrument. The depth of the body helps to amplify the vibrations of the soundboard before projecting it from the sound hole towards the audience. Therefore, to craft the best sounding acoustic guitar, it's clear what part of the instrument we should focus on.
The single most important part of the guitar, if you want to influence the sound and if you have to have a control over sound, is the soundboard and the bracing, which is basically glued underneath of the soundboard. The purpose of the bracing is basically to just hold the top board in a shape, you know. The strings are hooked and they pulling the top quite significantly. The load or the tension which is there is for a standard 6-string set, it's about 72 kilograms, which is pulling power over there on the one top. So of course the top board itself, which with very thin, maybe 3 point something millimeters, depends on the model, is not enough to hold it like that. So the bracing is just bracing the guitar against the tension.
But bracing can't just be placed where it would make most structural sense. Gluing bracing to the underside of the soundboard has a direct impact over how freely the soundboard can vibrate. So calculating the optimum bracing pattern so that it will not interfere with critical frequencies while still being structurally secure is an important part of the process.
You have to imagine different like wavelengths. They are somehow trying to fit into that soundboard shape. Play something with 200 Hz or let's say 1200 Hz. And of course, it will fit very differently. We are using this visualization actually for finding the way how to fit the braces in the soundboard areas which are resonating a lot in particular frequencies. They are free to resonate more, and you can use it actually in the other way. If you want to, so let's say, mute some frequencies a little bit, you can put a bracing in the way, and they will resonate naturally less. Or you can play with the sound by putting the brace in a different location.
To perform this visualization, soundboards are placed atop a speaker which can play a pure tone of any frequency Peter selects. By sprinkling on some fine sand and exciting the soundboard with the speaker, the parts of the soundboard which resonate a lot at that frequency will disperse the sand particles away, allowing the sand to settle into areas where the soundboard doesn't move. These are called node points, and by determining where the node points are across the most critical frequencies, it's possible to build a map of the areas of minimal vibration, which Furch can use to inform bracing patterns that won't adversely affect the performance of the soundboard. But the soundboard measurements aren't just to decide the best bracing placement. Furch have a proprietary voicing process which takes into account the inherent differences between soundboards, measuring the frequency response of each and every guitar top and then thinning out specific sections to fine-tune the individual soundboard performance. ensuring that natural variances in the material don't overtake the intended tone of the instrument.
Adjusting the thickness of each individual guitar, actually all guitars behind me over here, they went through this process. Every single piece of wood is slightly or more different. You can have a same material grading, like a AAA quality of material of the same species of the Sitka spruce, for example, but I can guarantee that each of them would have a different weight, of course, therefore different density, different structure a little bit, different flexibility, and with voicing we can sort of like narrow down the various acoustic performances, which would be might be like this big range of the acoustic performance out of that single top, but with the voicing we can narrow it down maybe to this kind of like a range, so we can have much more control over acoustic output. We can excite the guitar with the sound generator, and then by various sensors we can measure how the guitar is behaving. You can really see the contribution of bracing to the top board, and you can see contribution of the voicing to the same board, you know, because we were measuring by that methods which I described, how it's going through the process, a whole body actually, how it goes through the production process, and what each steps is changing with frequency response with that method. So you can see Lacquer, for example, how it's maybe affecting a little bit, and then you see the bracing, how it's improving significantly, voicing, how it's improving or changing whole frequency spectrum, actually, how it behaves.
To complement the strictly scientific approach, Furch also initiate tests where human operators strum the guitar to gauge the psychoacoustic properties of the instrument. Or to put that into less pretentious verbiage, they find out how the guitar makes you feel.
And then, of course, we are using our own instincts and ears and feelings to strum the guitar with our own hands or with a pick. And of course, this is much closer to the real life situation of the tone. So that gives you more like a real life picture. But disadvantage is that it's just done by hand, so you have some imperfection. But that's okay for some kind of tests. It's already been under development of many years. I think we started first version of our voicing process in 2008. So we have improved it over years. And in the production, it's much more smoother, faster, because that was essential. The guitar has to be produced in certain time, so it costs certain amount of money, and it's not too expensive for customers. The process of voicing itself takes a little between 5 to 10 minutes, and basically everybody can do that. You can do it if you go through our training process. It's not too difficult because we have prepared all the tools, but I will not show you how it's done exactly.
So there's industry secrets that you don't. It's all kept behind a locked door somewhere, and you don't really want it.
Sort of like that. You will not see. I can guarantee you will not see it on the video. Well, yeah, that cool thing about this approach and the reality we have achieved that is that everybody can experience results of voicing process on all our guitars, because all guitars, including Little Janes, Pioneers, Violet, up to the Rainbow series, of course, they all have this voicing process applied, and that's for me very important, that you can experience yourself on all Furch range.
A carefully crafted, scientifically measured soundboard capable of delivering precisely the tone Furch intends is only useful if the guitar can play effectively. Furch are using traditional materials to construct their guitars: spruce and cedar tops, mahogany and rosewood backs and sides, and mahogany necks, all susceptible, as all wood is, to changes in humidity, intake and release of moisture that over time can cause bulging of the top, twisting and warping of the neck, and even cracking under extreme dryness. Taking a cross-section of one of Furch's necks, we can see this unusual apparatus, which aims to minimise and even eliminate many of these humidity and stability-related issues. This is the CNR system, which stands for Composite Neck Reinforcement. Utilising a standard two-way truss rod, housed in a carbon fibre pipe which evenly spreads the truss rod's load across the entire length of the neck, joined to an aluminium skeleton in a fashion that increases long-term stability compared to a traditional wood-only joint, while allowing more of the soundboard to resonate freely, improving the sonic performance of the instrument as a convenient byproduct.
The CNR system in our guitars, we started to put it there maybe in 2016, 2017. We made over 60,000 guitars with CNR system in the neck. And yeah, the main purpose was to stabilize the neck, so we didn't want any reason for changing of the playability, you know, making the string action higher and so on in different environments. So back then it was a really great achievement. I think it's, even today, I think it's a very, very advanced way how to construct your neck. So CNR itself, it's solving one of the issues which we had many years ago, and I think it's quite common issue on acoustic guitar. So if you imagine how the truss rod works, truss rod is going from this point to almost to the end of the neck, and when you start to turn it, it starts to push in a certain area. Basically it pushes only at the edges of itself, so it starts to push over here and starts to push somewhere over here. It's common for all acoustic guitars, electric guitars as well.
The purpose of the truss rod is to provide counter tension to the strings and control over the relief of the neck, increasing stability and putting the neck into a playable state. But as Peter points out, tensioning the rod usually results in applying forces that are localized to the extremes of the neck, leaving little control over what happens along its length. Housing the truss rod in a stiff carbon casing helps to distribute these forces more evenly, giving a smooth gradient of control across the entire length to mitigate for the unpredictable behaviours of the natural material the neck is made from.
Some necks have a tendency to twist, some necks have a tendency to develop some humps and so on. So this is basically just the nature of the wood, you know, it's every piece is slightly different. And with carbon casing, for the truss rod, we basically have control over the neck in its whole length. Carbon being very rigid, it's basically transfers all that energy and deformation very, let's say, smoothly towards the whole length of the neck.
This behaves in conjunction with an aluminium skeleton structure incorporated into the neck heel. This acts to distribute tension load of the neck into the body in a controlled fashion, an incredibly important connection point for the performance and sound of the acoustic guitar. Now, seeing this arrangement may alarm purists, but the advantage is increased rigidity of the joint, much less susceptibility to wood-related movement over time, and an easier neck to set up overall.
Rigidity of the whole thing and the deformations happening on the guitar neck is much smaller than when you are using basically old-fashioned wood as a structural element of the neck and heel.
CNR has been a popular feature of these guitars for many years, loved by the players and guitar techs alike, as it allows the neck to require fewer and quicker setups. But Furch wanted to go further. The most common reason an acoustic guitar would require its neck angle reset is due to changing humidity. With wood able to take in and release atmospheric moisture, over time the soundboard can swell and shrink, lifting and lowering the strings with it, changing the playing action and making the guitar difficult or even impossible to play. But what if there was a way to adjust the neck automatically? What if Furch could find a simple mechanism that would tilt the neck in the appropriate direction as the humidity changed, keeping the string action consistent no matter the environment? And what if they could do it with one single block of wood that was just as susceptible to humidity changes as the soundboard?
We call it CNR Active. The structure is now designed a little bit differently, improving some of the geometries of the neck and so on. But more important is the active function. If you have a high humidity environment, then your top is lifting a little bit. And this piece of wood is expanding, behaving the same direction as the basically the same way as the top board does. So it's expanding a little bit and it's basically tilting the neck a little bit backwards. You cannot see it on the guitar. It's a very small move. It's very difficult to see, of course, and it is happening over days, not really in a second. But it's moving like that, tilting the neck. So it's compensating for the change which is happening on the top board, and your string action stays in basically your spot on position. If you are in a low humidity environment, your top basically sinking down, and this element is shrinking a little bit. Basically, they're releasing a little bit neck, let it go a little bit forward, tilting a little bit forward, and again compensating for this like a change on the string action. So it all works together. So all the humidity changes works together, and the main purpose, of course, to keep your guitar in a perfect perfect situation and perfect playability, so you can perform the best. By turning this screw, there is a small screw which is accessible through the sound hole with a special tool which we are providing, or you can purchase it actually on our eShop or with some of our dealers as well. You can access this screw, and by actually slight turns, slight adjustments, you can set up your string action. A couple of seconds, you can make it like a higher, lower, and basically find what suits you the best for your playing style. And that's powerful, I think.
The genius of placing a block of wood into the neck heel that is purposely designed to swell and shrink with humidity changes, automatically adjusting the neck to keep the string action consistent, cannot be understated. Present that same problem to most engineers and they'll likely come up with something far more complicated, with electronics and sensors and mechanised parts. Having seen the rest of Furch's factory, it wouldn't surprise me if many of those options were considered before realising just how simple this solution could be. With the amount of time and skill it takes to perform neck adjustments on acoustic guitars that feature traditional neck joints, not to mention how much it costs, this CNR Active innovation is going to save Furch players several trips to their luthier over the lifetime of the instrument. And it's not bad news for the techs either. Anything that can speed up their process and allow them to turn around more jobs in a day is deeply appreciated. The final piece of the puzzle for a great sounding acoustic guitar is the finish. In the world of electric guitar, the finish is largely an aesthetic concern, choosing lacquers, colours and thicknesses of finish based on how it will look, feel and age. In many cases, protection of the underlying wood isn't even a major concern. We just want a guitar with looks that will fit our own personal rule of cool. For acoustic guitar, the finish is a much deeper consideration, and it turns out you can't just pick up a generic tin of wood lacquer from your local hardware store, slap it on there and expect that to work. Which is why Furch spent a lot of time developing their own finish, so that it wouldn't compromise on the vibrational properties of their guitars.
So the finish is covering all that important resonator area actually, because the body is the resonator of the acoustic guitar. When you put too much of too soft finish on the acoustic resonator, then it of course like compromise the effectiveness of the resonator. Wood finishes are mainly designed and made for furniture makers. So since furniture makers don't care so much about this acoustic performance, then they are more care about just the protective and visual aspects of that finish. Then of course you can easily pick the one which is not very suitable for acoustic guitar. So when we were picking our finish years ago, when we were doing our internal research about what to use on our guitars, we looked through different materials which were out there on the market. We did not quite succeed. We didn't find basically the formula, the composition of the finish which we wanted for our guitars. But fortunately, there were some companies which were like willing to work with us to give us a little bit of their know-how and access to their research and development departments. And basically, step by step, we were able to put together some formula of the finish, which is suitable for acoustic resonators in general, wooden acoustic generators in general, I would say. Mix the, let's say, properties of the lacquer together in a way so it's applicable to quite complicated shape of the guitar body, and the edges, which are pretty sharp and so on. These finishes don't like this kind of stuff, they don't like sharp edges and so on. So we had to really fine-tune it so it works with acoustic guitar.
This has resulted in Furch developing a 100% UV cured lacquer, with molecular density during polymerization being so tightly packed that it produces an extremely hard finish. So hard, in fact, Furch need less of it to produce an equivalent level of protection compared to other available finishes. While an extremely hard and extremely thin finish is great news for keeping the guitar protected without compromising its sound, it does mean polishing the guitar becomes a new challenge.
And with extra hard finish, comes extra work. This extra work, it would bring, let's say, polishing of one high gloss body from 1 hour, about 1 hour, which was before with the previous version of the lacquers, to nearly 3 hours. Back then I was already kind of trying to figure out how to make it somehow, how to make the polishing and buffing somehow automatized, and that brought us to actually implementation of first robotic cell actually in our factory over here. So our finish, UV finish specifically, are polished by robots. So the robots, they do actually 80 to 90% of the job, and then what's left for my people is just the finishing touches, because there are some things which robots cannot do. If you fine-tune the technology right, it can really produce consistently very high quality. It doesn't have to if you don't tune it properly and don't engineer it properly, but it definitely has the potential. And so we're spending extra time on fine-tuning our machines and programs. Yeah, these two things, productivity, one thing, but increasing of the quality, another thing. These are the reasons why you see quite a lot of technology in Furch production. Yeah.
With fully programmable robot arms taking much of the physical labour off the shoulders of the human workforce throughout the process, reducing mistakes and improving efficiency, it did lead me to become concerned about just how secure human jobs are at Furch Guitars. There are clearly a lot of skilled people here doing incredible fine detail work, but are all of these automizations putting their jobs and income at risk? How many people have already been replaced by Peter's insatiable lust for technological advancement?
In our case, since we are always growing and we're always bringing new products, I don't remember any single time when I was implementing some technology and somebody had to go away from the company. Of course, if some technology is replacing some job, which ultimately happens, then it's still, we find another job and find some, we are always looking for people with skills, and I can always put some use for all people with skills. So that's not an issue over here. If you look at how many people work in the factory, how many people work per one guitar, let's say production a month, it's not like automotive, or it's not like a chip making, and it will not be like that as long as the guitars keep the same concept of the production and looks as it is right now. So it's still in guitar production still involves a lot of handwork, and it's not possible to make a guitar without human touch. It just doesn't work this way. It's not the kind of product which could be done this way.
What did I learn from my time visiting Furch Guitars? Well, other than confirming that I still love Koffala and that offering me free, unlimited Czech beer is an extremely dangerous thing to do, my biggest takeaway was just how much work goes into manufacturing one of these guitars. As impressive as all of the high-tech robotic processes were, with their precisely repeatable actions and pressure sensors that ensured adaptable performance to the unique properties of the instrument being worked on, it was the human operators that held my admiration. These are people who have incredible levels of skill, who are able to put the time and effort into the fine details because the automated processes implemented elsewhere absorb all of the tedious labour. People seemed genuinely happy to be working at Furch. They weren't bothered that their tasks were being interrupted so that a couple of foreign men could stick cameras in their faces and capture processes that were necessary for the narrative of this video. In fact, many of them seemed quite keen to show us what they were doing and had a great sense of humour about it. Maybe Peter did have a gun to their head and told them they better smile for the cameras, but I didn't get a sense of any of that kind of tension. It seemed to me like a relaxed environment. People had their jobs to do and they were doing them efficiently, but I also got to witness them on their downtime, where it was clear there was a great sense of family and community at Furch. What Furch produce are premium quality acoustic guitars. These are expensive instruments. Their base level Violet series starts around €1,000, with the exotic and personalised Rainbow series able to climb to €5,000 or even €6,000 for people with serious money to spend on a custom instrument. From the outside, those prices might seem outlandish, but after having visited the factory, understood the technology, and with the knowledge that this is all being achieved in-house in the Czech Republic without outsourcing any labour elsewhere, the prices start to make a lot more sense. And once you get one of these guitars into your hands, it becomes very clear the quality of these instruments. If you do want to find out more about the different instruments that Furch offer, including their Grand Nylon series, the new Spectra colour options, travel guitars like this Little Jane that can fold away into a backpack sized for aircraft cabin luggage, and even their limited runs of acoustic basses, you'll find a link to their website in the description below. But that's all for now. Keep it loud and stay safe.